So here it is. The extra credit is asking us to, we are given the revenue, 50x, the cost, x to 2/3 plus 750. And we're asked to find the average revenue. So also it's asking about the average profit as well. So let's write the profit as the revenue minus the cost, which will give us 50x minus x to 2/3 and minus 750. So now the problem is asking us to determine the average revenue, average cost, average profit. So we're not asked to differentiate yet. So for the average revenue, I have revenue divided by x, which is 50x divided by x, which is 50. Is the revenue per unit. The average cost, that will be C of x divided by x, which will be x to 2/3 plus 750 divided by x. The denominator is one term, and I will separate the fraction into x to 2/3 over x plus 750 over x. Copy the base, subtract from 2/3 1, and I get negative 1/3, and then plus 750 x to negative 1. Earlier today, what problem was that we want to exclude from the homework? Do you remember the one with the product? Do you remember which number? I think it was like number 5 on 1.6. Okay, number 5 on 1.6. When you get to it, you can skip it. Because whatever you put in there, it may give you an error. And I'm not interested in completely simplifying that till the end. But this is okay. This is not as crazy as that one is, right? So x to negative 1/3 and 750 times x to negative 1. Do we understand this? Yes, everyone? Is it clear how we got it? It's okay if you say no.
1/3 from the 2/3?
Yes, 1/3, I subtract 1. 2/3 minus 1.
Oh, okay.
Copy the base. From 2/3, I subtract 1. And then copy 750, and 1 over x is x to negative 1.
Okay.
And then the last one, which is profit, average profit. That is this, which will be 50x minus x to 2/3 minus 750 divided by x. And I just have these put together. I don't have to do it again. So this will be 50 minus x to negative 1/3 and minus 750 times x to negative 1. I subtracted this from this because I already did it once. But in part B, the rate at which the average cost, just the average cost, is changing when 8 items are produced. So now I'm asked to find the average rate of change when x is 8 of the average cost. So I have to differentiate this and then plug in 8. Is that clear? Yes. So the question is saying, find the rate at which the average cost is changing when x is 8. So I look at the average cost, I find the what? That will give me the rate of change. I find the derivative of the average cost and then plug in 8. Is that better, everyone? Okay, so this is it. This is the average cost. I will differentiate it. So C of x over x prime. You don't have to use anything here, the quotient rule or anything. Please don't. You already have the function. So bring down negative 1/3. Subtract 1 from the power to get negative 4/3. Minus 750 x to negative 2. One more time. I bring down negative 1/3, but I subtract 1 from negative 1/3. That's how I get negative 4/3. I bring down negative 1, multiply by 750, and subtract 1 from negative 1. Now, in the function as is, and I want to show you how, just right here, x equals 8. So here's what it means. This is the function, and we want to evaluate it when x is 8. You don't have to write this one more time. You don't have to plug in 8. Just put a vertical bar and say x equals 8. And now we're going to write the answer. So let's put this in the graphing calculator from scratch. So I see negative 1/3. You know me, I put everything in parentheses. Bless you. Negative 1/3 multiplied by, in parentheses, 8. Close the parentheses, caret for the power, in parentheses, negative 4/3. You have to put in parentheses because it's negative. And it's a fraction. And then minus 750. And in parentheses, 8. In parentheses, close parentheses, caret. You know me, I put parentheses because it's a negative number. And it's negative 2. And this is negative 11.74 dollars per unit is how fast the average cost is decreasing when we manufacture 8 units. Good. Anything else that you would like to work on?
I think we've neglected one.
That's not neglected. Very good. So let's do number 1. And here we have f of x, 2 minus x over x plus 3. Find the domain. Find f of negative 3, f of 0. Oh, yes, of course. I'm sorry. Thank you. And find the difference quotient. So we're given this function. We're asked to find the domain, the value of the function at negative 3, the function of value at 0, and the difference quotient. Let's start with the domain. How do I get the domain of this function? Very good. So then the domain will be negative infinity, negative 3, union, negative 3, infinity. What will you say of about f of negative 3? What will you write? Good. How much?
So 2 minus negative 3 over negative 3 plus 3 is 5 over 0.
Good. What is that? Very good. Good. And f of 0? Very good. Awesome. So now we are left with the difference quotient. So difference quotient is f of x plus h minus f of x divided by h. The only thing we didn't do in college algebra, we really didn't work with rational functions. We worked with radical and mainly quadratic, but we didn't really work with rational. Okay, so let's do that. So this is 2 minus x minus h, careful, over x plus h plus 3 minus 2 minus x over x plus 3, everything divided by h. Is this clear? 2 minus x, but x is x plus h, and I have to distribute x plus h plus 3, and I copy the function. Agreed so far? Great. Great job. I need to find the least common denominator, which I know is x plus 3 times x plus h plus 3. So this one needs an x plus 3, and of course this one needs an x plus h plus 3. I know what has to happen, right? Whatever I write here, all terms without h must go away. Eventually this will go away at the end. Okay, I distribute x to these 3 terms. 2x minus x squared minus xh. I distribute 3 to these 3 terms. Plus 6 minus 3x minus 3h. Minus 2 distributed to these 3 terms. Negative 2x, negative 2h minus 6. And positive x distributed to these 3. Plus x squared plus xh plus 3x. I will immediately stop if terms without h don't go away. I will say, oh, oops, I made an error. I'll start from scratch or whatever you want to do. So let's see. 2x with negative 2x, x squared with negative x squared, positive 3x with negative 3x, positive 6 with negative 6. Even an extra term, that's a bonus, negative xh with positive xh. And I see there are two terms remaining, and they add up to negative 5. So now I have negative 5h over x plus 3, x plus h plus 3 times 1 over h. And the simplified form is this. Since you know limits and you know the difference quotient right now, if you were asked to differentiate that function, what would you get? What would you have gotten? Negative 5 over. It's the limit when h approaches 0. Negative 5 over.
X plus 3 squared.
That's it. Exactly it. Absolutely. Because that's, if I just put the limit in front as h approaches 0, that's what I get. And now I can even differentiate to see if I get that. With h approaching 0, of course. Good. So let's go over quickly. This is done. This way, number 2 we did not. Number 3, yes. Number 4, yes. Number 5, yes. Number 6, yes. Number 7, yes. And I know you don't have difficulties with that one. We've done almost all of them. Now, if you want to do this, we can. Yes? Okay, so 3x over x squared minus 4 prime. And then we did this, and we did the extra credit. So basically, there is only one problem left after this one, right? Just number 2, nothing else. Okay, very good. Remember, this is a constant in front. Leave it out. Don't waste your time with it. If you have 3x plus 5, you cannot do this. If you have 3x plus 5 or minus 3 or whatever, you can do this. But since the numerator is 3 times the number, you can put the 3 in front. The top prime, 1, times the denominator, minus the top times the denominator prime over x squared minus 4 squared. It's okay if you use the method from the book or twist it a little bit. I'm fine, but be careful. So the top prime is 1 times the denominator minus the numerator times the denominator prime over the denominator squared. Yes, this one we have to simplify as much as we can. 3 can still stay outside. X squared minus 2x squared is negative x squared and minus 4. X squared minus 4 squared. All I can recommend is put the minus in front and the 3 and x squared plus 4 over x squared minus 4 squared. This is useful for the next chapter. That simplification is useful. Any questions?
So what if you didn't bring the 3 out?
And then you'll have more work to do. You have bigger numbers.
Yeah, but would it should result in the same thing?
Absolutely. Yeah, you will just have 3 times x squared minus 4. You have to distribute. More work. But you will absolutely get the exact same answer. So now let's look at f of x, which is the square root of 2 minus x for x less than 2 is 0 for x equals 2 and x minus 3 for x greater than 2. Now, this is very important to be able to graph a piecewise defined function and analyze and answer questions based on that. So this is very important. So every time I'm asked to graph a function, the first thing I need to do is find the domain, please. They're very good. So this is basically negative infinity to 2. Would you agree? This is basically 2 to infinity. So the function is defined between negative infinity and 2, is defined at 2, and is defined between 2 and infinity. Can anyone give us the domain of this function?
Negative infinity to 100.
Very good. Next. Zero must be in the table. 2 in this case must be in the table. Look at what happens at 2. There is a parenthesis facing left, a parenthesis facing right. So I have to leave some room for this value. When x equals 2, the function value is 0. On this interval, because these may not be arranged in the correct order, on this interval between negative infinity and 2, I have to use this function, the square of 2 minus x. Obviously, for 2 to infinity, I must use this function, which is x minus 3. On the left, I'm going to choose also negative 2. And when I plug in negative 2 with negative in front and plus 2, I get the square root of 4, which is 2. When I plug in 0, I get the square root of 2. When I plug in 2, and you should say no, you're not allowed to. True, but I have to. So 2, I get 0. Inside the parenthesis, I get 0. When I plug in 2 on this side, inside the parenthesis, I get negative 1. And when I plug in 3, because it's a linear function, I get 0. These are the minimum possible points that I have to present. And now let's graph the function. Now, from the table, can you say whether this function is continuous at 2? The limit from the left, limit from the right, and the function value, are they all the same? No. So the function is not continuous at 2. Because the limit from the left and the function value are the same, the function is continuous from the left. Is it continuous from the right? No, because the function value and the limit are not the same. Is this function continuous at 3? Of course. The limit from the left, the limit from the right, and the function value are all the same. It's a linear function. So the function will be continuous at 3. But we have to put that in writing. So let's graph the function first. Please dictate from left to right the first order pair that I need to plot. Very good. Right here. Then 0, the square root of 2 is somewhere here, 1.41. 2 comma 0 is here. And 2 comma 0 is this point. So all I have to do is connect not as a linear function. This is the square root. It's not a linear function. Then on the other side, I have 2 comma negative 1. But 2 comma negative 1 is here. And this is an open point. And 3 comma 0 is right here. And this is a line. It is very clear the function is not continuous at 2. Is it differentiable at 2? A function, if it's not continuous, it cannot be differentiable. Right? So the function is not differentiable at 2. Is it continuous at 3? Of course. The limit from the left, the limit from the right, and the function value are all 3. So I have to put that in writing. At x equals 2, limit as x approaches 2 from the left of the square root of 2 minus x does not equal limit of x minus 3 as x approaches 2 from the right, which does not equal f of 2. Not continuous at 2. I can say at x equals 2, jump discontinuity. Is it continuous at 3? Yes. I will write at x equals 3. The limit as x approaches 3 from the left Oops, sorry, I'm going to erase that. It's x minus 3, just x minus 3, equals the limit from the right and equals the function value of 3. This is 0, this is 0, this is 0. So the function is continuous at 3. Continuous at x equals 3. So now let's answer the questions. We graph the function. Please present the table of ordered pairs that you use to graph. Please. This is mandatory, please. Okay, so now let's answer. The limit from the left of 2. I don't even have to look at the graph. The limit from the left of 2 is 0. The limit from the right of 2 is? The limit for the f of 2 is? And the limit from either side of 2? Perfect. The limit from either side at 3? 0. And then we already completed this. Is continuous at x equals 2? No. Explain and how it does apply or does not. Continuous at 3? Yes. Limit from the left, limit from the right, and the function value are all the same. But I will put it in writing, of course. I will say limit of x approaches 2 from the left, just simply f of x, I'll say 0. Limit of f of x as x approaches 2 from the right, I will say -1. Limit as x approaches 2 from either side, d and e, as you just told me. Next question. Is there anything, would you say, we do have 10 minutes. Is there a particular problem that you'll say, well, if I see this on the test, I may not remember, or I may need another problem right now, whatever. I highly recommend between now and Thursday, we do the problems we did in class and make a list of questions, because I like to answer those questions before I start chapter 2. I have to start chapter 2 on Thursday, which will not be covered by this test, of course. Okay, so any problem that you think we should redo now, or another one, similar one, anything, any type. Any type of problem.
Another one about the higher order derivative.
Yes, of course. So let's choose. So these problems are in 1.8. In 1.8, if anyone wants to choose. Page 172. Maybe we would like to look at a word problem. Maybe we want to determine sales, population. We did population last time, I think. Medicine. Or simply just differentiate a function. Just want to differentiate?
I don't have the books on all the options.
Okay, so let's look at, let's say, anyone wants to choose? I don't even know what to choose. Yeah, let's look at 40. 40. One more time, page 172. And we're given y equals x to the 7th power minus 8x squared and plus 2. We're asked to find d6y over dx6. What does that mean? The 6th derivative. Very good. So let's find dy over dx first. And we get 7x to the 6th minus 16x. Perfect. d2y over dx2. That's the 2nd derivative. Minus 16. Perfect.
You have to do them all until you get to 6.
Say it again.
You do them all until you get to 6.
You have no choice.
Oh.
You can jump. And when we get to integrals, we have to go back slowly and surely, step by step, till we get back to the function.
Okay.
Yes. If we get, for example, a third derivative, and we're asked to find a function, we have to find the second derivative. Then we have to find the first derivative, and then we'll be able to find the function. There is no other way. d3y dx3.
210 x to the 4.
d4y dx4.
40x to the 7.
2 more. d5 over dx to the 5th. 500. Thank you. X squared. And finally, d6y over dx to the 6th, the 6th derivative. It's 5, right? 5040x. Any questions? Any questions?
So you couldn't just assume from the beginning, couldn't you just work from, or with x to 7 and just cut off the back end off?
Well, yes, you could, but you still have to show all steps.
Okay.
Yeah, you still have to show all steps. Because each derivative is important, has its own. Okay. Is there any other, we still have 5 minutes, any other type of problem that you would like to go back to? So are we okay with the difference quotient? Yes.
I was gonna say, can we do 36 on
Yes.
172?
Yes, 36. $36. 2x plus 3 divided by 5x minus 1. Let's see what they want. For this one, they want the second derivative. There is no way we can determine the second derivative without determining the first one. So either you write y prime or dy over dx. It's up to you. Remember the quotient rule. It's the first function over the second function, and we differentiate. The top function prime is 2 times 5x minus 1 minus. I copy the top, and I differentiate the denominator. What do I get? Very good. Divided by 5x minus 1 to the second power. I have to fully simplify this. Because if I try to differentiate this, it will be a mess. So we do have to fully simplify this. So I have no choice. Notice that here I could not leave a constant outside because there are 2 terms. But if I only have 2x, I will leave 2 outside. I don't care for it. You can wait. But here I can't separate anything. So then I have 10x minus 2 minus 10x minus 15 divided by 5x minus 1 squared. I like it. Why do I like it? Exactly. It will be a mess. So this is negative 17 over 5x minus 1 squared. Now, what do you think I'm going to do next? Because I need to find the second derivative, d2y over dx2. The second derivative of y with respect to x. What do you think I'm going to change this into? Obviously, I don't want to use the quotient rule. Negative 17 times 5x minus 1 to the... Exactly. And now when I differentiate the second time, I have negative 2 times negative 17, which is 34. 5x minus 1 to the... Very good. Times the inner function prime. How much? That's it. Now I can go back, multiply those two, and bring back 5x minus 1 to the third power. 150, 170, right? Otherwise, you'll have to work harder. Why did I do that? Why was I able to do that? Only because the numerator is a number. If I had negative 17x plus 5, I could have not done that. So remember the key words, right? Simplify factor. Descending order. No negative leading coefficients, right? That's another. So I changed that like this because it's easier for me, right? I made the whole thing easier than differentiating as a